In today's Python Pandas video, we're going to be taking a look at the expanding window function. Now, this is very similar to rolling, which we covered in a previous video. The difference is rolling looks at a specific window for their calculations. For example, if you want to take a look at the mean over the last 5 data points, whereas expanding will constantly update based off of all the data points, which is really helpful if you want to take a look at how the mean changes over time or standard deviation. There's actually quite a few examples that we're going to cover in this video, 10 plus. So rather than ramble on for this intro, make sure you grab a Python notebook and let's start coding. All right, let's get started. So what we're going to do is import pandas as PD, then import numpy as np. And what we'll do first is essentially set up our data frame for the video. So a few different steps that we're going to have to take on that side of things. Now, if you do want all the data from this video, it is going to be linked down below in the article. Should be ready by the time this video is out. But first, what we're going to do is have this list over here, and then we're going to pass this list into pandas data frame here. And I'm just going to copy paste this because we also have columns. So we'll have columns date, venue, city, state, capacity. We'll expand this out a little bit later in the tutorial, but this is what we're going to start off with for our first example. And just to show you what this looks like, I go here to df and do a head, right? Date, venue, city, state, capacity. We're good to go. So let's jump right into it. And the first thing we're going to take a look at is the cumulative mean. So example 1, right? And what we'll do, and also I should mention all these examples should be pretty much in order on the article. Obviously, we'll try to improve the article over time. So if you're watching this in a year or 2 years in the future, it might be slightly different on our website. But yeah, so what we're going to do is find over here expanding average. So we can just go over here, E average or expanding average, right? Doesn't really matter too much for naming conventions. Although when you're doing real world data analysis, naming convention doesn't matter. But this is a tutorial. So what we'll do is over here, it will look at our capacity. So say capacity, and then we'll say dot expanding, and then you just do the mean, right? And we'll run that. And what you'll see, if I go over here to df, see how the mean interacts over time, right? So we start off, the capacity is 21,000, so 2121. Then we have a capacity of 19,891, so it decreases again. St. Augustine at 4,700, so the mean keeps on decreasing, and it goes throughout our entire data set. Now, I didn't actually mention what our data set is, so I apologize, I went too fast. So one of my favorite artists is Billy Strings. So this is a hypothetical tour that he does, right? So the date of the concert, the venue, city, state, and then the capacity for it. Some of these are real dates, some of them are synthetic. So there's that side of things, right? We have that over here. And what we'll keep doing is move into our second example. And what we'll take a look at this is expanding the difference from the mean. Finding, man, mean. And what we could do on that, there's two different approaches. We already have the expanding average, right? So we could just subtract out what we have. So like you could just go over here. I'll show you this, right? So we have the average going across the board, right? So what we could do is diff from mean 1. We'll say that is equal to df capacity minus this, right? Or you could technically just go across and take our capacity, subtract out same code that we had above over here, right? And this will just show you the difference from the mean each time. Either one of these works, and I'll just show you. We'll create 2. I'm just going to bring this to another cell right there. So 1 and 2, and if I just go to df, these are going to be equal, right? And what you see, different from the mean, 0, or sorry, 1 and 2. These are 0 because we have 21,000, and it starts changing, right? And pretty impactful data points if you want to take a look at that, right? The farthest away from the mean, the closest to the mean, etc. So there's that side of things. All you want to take is your capacity in this side of things, or your one column. Then you subtract it from the mean that we have through expanding, right? Or you can just do this all in one line like that. You take your column and then you just do dot expanding dot mean. So I think it's pretty cool to show you guys that. I was going to probably show a little bit later in the video, but I figured might as well do it when we're working on our mean. All right, so next we're going to look at cumulative sum. Cumulative sum, it's going to be example 3. Yeah, let's jump right into it. So pretty easy. We'll say df cum sum equals, and then just df capacity. Like, what's the full capacity throughout the tour? Dot expanding, and then just dot sum. And I'm not going to show you everything that we could use with expanding, right? You can see over time this changes. So maybe I'll just put like head 10 so it doesn't take up too much room, right? You can see just keeps adding up all the way down. Another one that's pretty important or pretty cool to see is the minimum or maximum. So it will hit the min or maximum across the time and anytime it gets updated. So what we can do is df, and we'll get exp min, and we'll have df exp max. And this is just going to be equal to df capacity, say dot expanding dot min, dot min, and then just max. Again, there's so much that you could use this with. We'll be jumping through a lot of other examples, but another common one to do is just the standard deviation. Go here to max. And just to show you what this looks like. Now, this is probably the last time I'll grab all the columns. You won't need them all. But you can see going over here, the min and max with both 21,000, right? Then you'll see a min of 19,891 because that was over here. Well, max is still 21,000. I wonder if max was just 21,000. Nope, we have 27.5. The min's 4,700. So it just changes as more data is read, right? It'll give you the min and max up to that point. And then if it sees something different either on the minimum side or the maximum side, it will change. All right. Okay, so now let's jump into different columns. So this is different columns. And what we'll have to do is generate a new column first. So I'm going to do that. And we'll generate something called tickets sold. So if you watch my other video, it's going to be the same exact code. If you have not watched the rolling video, slightly different for you guys. So we'll go over here and just say tickets sold. We're going to go over here and write a little bit. So we'll say df capacity times np.random.uniform. Passing some values, 0.9, 1.0, length data frame. And then we're going to say as type int, as type, and pass an int because you can't have a fraction of a ticket sold. And I just want to do a head of 5 just to make sure that this is working really fast. And yeah, so that's working awesome. And what we'll do, I don't know why I just deleted that. We'll just go back over here and redo that because I'll probably put an article a little bit. Head 5. Great. Okay. So now what we'll do on this side of things is generate multiple columns. So what we'll do over here is generate the mean for both the capacity as well as the mean tickets sold. So we'll say df e, we'll make sure double brackets, e venue capacity mean, and then our next one will be here as e venue tickets sold, right? And then we're going to say this is going to be equal to, grab both of these columns, so df over here, capacity, and then also what we're going to want to grab is our tickets sold. So grab that, so tickets sold, again, since multiple columns, double brackets. And then all you gotta do is dot expanding like that, and then dot main, right? And now we generate both of those columns. We'll just do a head of like that. And you can see venue capacity, tickets sold, and across the board. All right, let's take a look at aggregates. So this one just showed you mean, right? What if we want to see like the sum and standard deviation? So we'll go through that. Ag example. And we'll just say expanding stats equals df capacity dot expanding dot ag, and then just pass in a list of what you want to take a look at. In this case, I'll say I want to look at the mean, I want to look at the sum, and then also the standard deviation, right? And what this will do is create a new data frame for you guys. And look, mean, sum, standard deviation, we have all these indexed, and you can see over here, right? Awesome. So now what we'll take a look at is a group by example, which is also pretty common to use with this. So we'll say group by example. And what we can do on this is df, and we'll say sold tickets city. Let's do sum, right? And we'll say df.groupBy. We'll pass in first the city, then we'll do tickets sold, so tickets sold. Then over here we'll say dot expanding dot sum dot reset index level equals 0, drop equals true. All right, and we should be good over here. City is capital C. That's why this bugged out. I'll just make this a capital C, and we should be good now. And what this will do is sum the tickets per city. So we'll just go df. We'll just throw in our city first. So city. We'll do tickets sold, and then lastly, what we'll do is grab this new column that we just generated, just to show you that we've grouped by the city. Right. So you see Atlanta, right? Tickets sold increases. Then we go to Nashville, no difference. And then once we have 2 nights in Nashville, it increases. And then St. Augustine, right? Tickets sold 4303, 4303, 4257. So increases each time over here. And values are essentially reset for each city, right? Tampa's first time seeing that, 10,270. Okay, so there is that side of things. And for some of you guys who don't know who Billy Strings is, technically plays like a jam band. So these are bands that will play multiple nights at a venue and have different set lists every night. So that's why you see, for example, St. Augustine 3 nights in a row that were played, or Nashville 2 nights, or Atlanta 2 nights. Completely different set each night. All right, so we're now on example 8. So example 8, and we're going to look at expanding with shift. What expanding allows you to do is access data that's either like a row above or a row below. You could specify also. It doesn't necessarily have to be that specific one. Like you could take a look 3 concerts out, above or below as well. In this example, we'll just take a look at a shift of 1. And yeah, let's take a look at that. So we'll say over here, df expanding shift. And all you have to do is equal to df capacity. And by the way, if you haven't used shift before, I do have a full video on the channel on it. Part of this pandas playlist. So I say expanding mean, and we'll do shift 1, and then we'll subtract df capacity, right? All right, so let's jump into our next example. And what we're going to look at this is ranking values on this side of things. And we're going to do it cumulatively. So this is an interesting one. So ranking values, because we're going to use apply as well by using apply. And let's jump into it. So we'll say df, we'll say expanding rank. And we're going to say this is equal to df, and we'll look at tickets sold. So tickets sold dot expanding. And then now what we're going to do is dot apply. And we'll write a lambda function in here. So we'll say lambda x, and we'll go pd.series x.rank. Say iloc -1. All right. So now what this will do, and I'll just go over here to df. We'll grab tickets sold. So grab tickets sold, which I already put in there, and then also expanding rank. So check this out. This is really cool. We'll jump here to the beginning. All right. And actually, we should change this over here. I'll put ascending equals false. Ascending equals false. And let's rerun that. Awesome. So let's say I wanted to rank the tickets sold each night, right? So obviously your first night, 19,686 tickets sold. So that'll get a rank of 1. But now for night 2, right, 20,896 tickets sold. Well, that is the newest. So we need to put that as a rank of 1, right? Technically, if we were doing a rank in general, this would be 2. But when this data was first read in, it is the first rank. Let's look at our third consort, right? 19,357. Well, that is the third highest in ticket sales. So that gets a rank of 3. 19,092, fourth, right? And then we do have some ties. So we could specify how we want to deal with ties if we want. You could just expand out this lambda or add in additional parameters, right? But we have a tie, so that's why we have 5.5 there, 4257, 7. And there's a lot of different ways that you could specify what to do with ties. Typically, it's a common interview question, funny enough, and maybe we'll make a video on that in the future. But yeah, you can see it constantly adds it in based off of the rank. In 25,133, well, this was the first at that time, the highest, and that got assigned the rank of 1. So again, kind of showing you two different things. Number one, you could use expanding to use it with ranks as something comes in with data, which I find it pretty helpful. And additionally, what you can do is use apply with it, which we've covered apply a little bit earlier on the channel, although we didn't get into this type of an example. And lastly, I believe this is like example 10. What I want to take a look at is min periods. So min periods is one of the parameters. So what I want to do is say df expand mean. This is like the third time we've done it. So we'll say 3 equals df tickets sold. Well, I should say expanding tickets sold. Mean. That's definitely not the third time, but we'll just keep it like that. df tickets sold mean. Then we'll do dot expanding. And then inside over here, we'll say our min periods. So min periods equals 3, and then we'll do the mean. So mean like that. And there's a lot of ways that you could deviate from this and like really expand on it. But what you'll see now is if we go to the top, right, we have null values because we specified 3, right? So we won't have any values until the third one, right? So we're not calculating the rolling mean until we get to that third row with our index of 2. So that's why those are null values over here. So by default, when we don't have that, we'll have values here. If you put 5, right, you'd have no values until 5. That is one of the things, right? On when we talked about rolling, using min periods allowed us to fill in some of these null values. If we set min periods over here with expanding, we actually generate some null values. But yeah, that's pretty much it for the expanding video. Went through about 10 examples with you guys. Again, there's quite a different ways that you could use it. Just remember the difference between expanding and rolling. Rolling has a specific window, whereas expanding will take a look at all of your data. I showed you how you could use it with sum, right? Cumulative sum you could use through expanding. Showed you how we could use the average as well, which is pretty impactful. Showed you how you can essentially run this with multiple columns, finding aggregate calculations. We also went to some more advanced use cases, right? Group by on that side of things. I wouldn't call group by advanced, but once we started getting down over here with shift and then using apply, I would say that's a bit more advanced. And then lastly, min periods, not advanced, but something that probably should have been brought up a little bit earlier in the tutorial. Anyways, thanks guys for checking out. Thanks guys for checking out this video on expanding within Python Pandas. And if you found it valuable, make sure to subscribe to the channel. We're uploading a few different data science videos every single week. A few links down below in the description I think will be helpful for you guys. We have the code for this article, as well as a link to our Discord server, as well as one-on-one mentorships. And if you want to continue this series on Python Pandas, well, you could click right over here.